Hey guys, welcome to the channel IF 4.2. This is Ajay.
So today we will be seeing Q as a fixed resource. We have already completed two videos, part 1 and part 2 in detail for understanding of source, and now we will understand in detail about Q as a fixed resource. So Q is nothing but a buffer. So a buffer is a storage area between two entities where we can store our produced part or the parts which are going to get produced. So buffer can be used for raw materials, can be used for finished goods. It depends on the modeling logic where we need to use Q, that is buffer. So Q has its own set of properties which we will be learning, understanding. More or less the properties are similar to the source which we saw, but there are some unique properties only for Q which we will be seeing in detail. So the statistics are same as like source. So we are having state, we are having throughput, we are having content and stay time. The template is similar as the source. Visuals properties is also same. We can change the color, we can change the shape, and we can change its location, rotations, dimensions. In more visual tab, we can put the 3D texture, we can check and uncheck all these flags, just like to show the name, show the ports, show 3D shapes, and so on. The queue has its own unique properties, as you can see here, this queue tab. So this is the maximum content. The labels, it is similar to what we saw in source, adding number label, adding string label as per our requirement. So in the queue, the maximum content is the maximum amount of parts which will be present on this buffer. So we can specify that how much it should be, 1000 parts, 10 parts, or it can be 20 parts. Depending on the requirement, we can specify the buffer capacity. Then we have item placement. In the item placement, there are four options how this buffer should be filled, whether it needs to be filled vertically, horizontally, or it needs to be stacked inside queue, or do nothing. So this queue item placement property, we will check it one by one. So we'll start modeling, we'll bring out the source, we'll drag and drop it here. Once the source is arrived, we will make a connection between source and queue. We will click on the source, we will change the sourcing, that if we will make it available at 0, that is instant arrival, and inter arrival time will make as 2 seconds. So every 2 seconds we will be having part from a source. Flow item is already selected, box, and the style is already selected, inter arrival time. Now what we are going to do is we are connecting this queue to another queue ahead. So we have this thing. So now what we will see is here capacity of the queue is 20. Here capacity of the queue we will make it as say 15. And one more queue we will make ahead, and its capacity will make it as again 20. What we'll do, we will keep capacity as 20 for all queues, so that in order to avoid confusion, and we'll make another fourth queue buffer with the capacity of again 20, and we will put different styles item placement things, and so that you can visualize at a time what differences we can get it. So we have do nothing on Q4, Q3 stack inside Q. Then we have horizontal line on Q2, and we have stack vertically. So now we will reset it and we'll run it. So the part will directly go at the end first, because this buffer needs to get filled first, and then we'll have this coming backwards and then backwards and then backwards. Now see, this queue has been filled with the buffer of 20. You can see this input is 20, content is 20. When this has the placement style do nothing, it means that you cannot see anything. You can only see one part on the queue, even if it contains 20. So this is the do nothing item placement. Then for a Q3, you can see in the statistics we have 20 output and 20 input. That means the current content is 20 parts as per our specified buffer capacity maximum content 20. Now this is the style stack inside the queue. So you can see by this it is very well stacked inside the queue perfectly. By calculating the dimensions of the boxes and the dimensions of the queue, it has placed perfectly. This is the item placement stack inside the queue. Then this is the Q2. We have put horizontal line buffer. So you can see this 20 parts are horizontally placed. And for Q1, we have stacked vertically. So you can see here it has been stacked vertically. So these are 4 item placements. You can see. Then I'll reset the model. And I will make this to stack inside the queue for Q1. Why I am making this way is we need to understand different properties below, and I'll delete these queues because it will take a lot of time to get Q1 filled. Now we have only one queue which has having a property of stack inside, because for other placements, I guess like for do nothing we don't have the stack based Z, and for other placements we have this. So what I'm going to do is going to use stack inside queue, and the stack base Z is nothing but the datum. So it states what should be the distance the part should be placed on the queue from the ground. So this is at 0.1 meter up from the queue the parts will be placed. So I will make this as 1 meter, and we will see how the difference is. So you can see the parts placement has been started 1 meter above the queue. So this is the property. So I will make it as 0. Then it will be started on the queue. Now if you see this property, last in first out, now this is the property utilized for which states that when the last part inside the queue will be coming outside from the queue first. So this is last in first out. So say I am producing part 1 first, then 2, 3, 4, 5. Then the queue will release 5th part first, then 4th, 3rd, 2nd and 1st. This is last in first out. Then we have perform batching. Perform batching is the property where you can batch the parts. So this is the target batch size, so you can put it 5. So 5 boxes will form one batch, and the maximum wait time is the time which is required to specify that how much time it should wait to have the target batch size done. If the time we are putting as 1 minute, and in 1 minute we are not getting 5 parts to perform a batch, then if we are having only 3 parts, the batch will be released with 3 parts. So that is maximum wait time. We can activate it. Then we have flush content between batches. So this is a content property used in order to break the batches. So if you are checking this up, the moment batches are done, it will be sent it ahead. Then this is flush content between batches. Then this perform batching done. Now we have this as output tab. In the output tab, you can see mostly these are all similar to the source which we have seen. First available, whichever first available queue is going to be present, it is going to send the part to that queue. Then we have by expression, we have shortest queue if applicable, longest queue applicable, random, round robin, conditional ports, by time of the day, matching item labels. So you can see all these properties for output from the source video. So we have already explained that in detail. Then we have use transport, and we will see this one here in the output. So we will make the models accordingly. So I am pulling one operator outside here, and what we will do is we'll go with the basic thing, that is current dot center object connected 1. So by S connection I am connecting operator to the queue. I'm putting processor ahead, and from that processor I'm putting a sync ahead. Processor I will put the cycle time of 10 minutes 10 seconds. Okay, and I'll reset now. And what I've done is I have told to use the transport at the output of this buffer. That means the operator 1 will be lifting the part and sending the part ahead. It will not go directly. So you can see the operator is performing the task. It lifts the parts, that loads and unloads on the processor. So this is the feature of use transport. This is the basic current center object. This is the first feature, object connected to a center port. Now center port by case. Center port by case means if the case is 1, if the case is 2, the port selection will be 1 and 2 depending on the item type. So what I'll say is, like, I will put two operators here which are center connected to the queue, and I'll make schedule as we have learned how. So what I will do is I will use sequence, arrival sequence. I will put one label which is named as type, and I will make two arrivals because I require two types, that is first type, second type, quantity 1 and 1, and I will repeat this table. So I will have in sequence first part, then second, then first, then second. I will reset this. So what this logic should do is, when the item type is 1, first operator will go. When the item type is 2, second operator will go. So we'll reset and we'll check whether it is doing accordingly. So you can see the operator 1 goes for type 1 and the operator 2 goes for type 2. So this is the another property we have seen for queue for use transport center by case. Then we have by global table VLOOKUP. By global table VLOOKUP is, we need to, like, from the global table we will be selecting the port. So in the global table we will put the value 1 and 2, and if the global table value changes, the port value will change here. So it's not so difficult. Then no transfer reference, so it will do nothing. We'll check how it works. So just see. So the word itself specifies no transfer reference. It is not going to transfer anything or not use the transport system. Then we have use list. This use list topic, as told in source also, we will see this use list in detail in future. It is a very large topic. Then object by name. So object by name direct. So directly you can select, I want operator 1. So only operator 1 will be performing the work. No another operator will be performing the work. So this is what is this feature of object by name. We can directly select from this tab here. And another in the object by name is by global table lookup. So in the global table you need to put the value of the operator which you need to use, and it will read from that row and column which operator we need to use. So this is object name by direct by global table lookup. Then we have customized logic. In the customized logic, we are having 5 types. Fifth type of process flow use task sequence subflow. This is again a deep topic we'll learn in upcoming future videos. The conditional transport, tagged resource, multiple transport option, and free operators is the customized logic properties. Then we have custom task sequence, 3 options, then task executor as a flow item, and A star task executor as a flow item. So we have created a model here to save the time, and what we are going to learn is we are going to learn customized logic and custom task sequence tabs here. So custom logic is the conditional transport. In that, first is conditional transport. In the conditional transport, uh, it specifies that as of we will delete this dispatcher and we will only connect this thing. So what we have done is we have used a combiner here. We are palletizing the part and we are sending it ahead. So this is the use of the combiner, and conditional transport here. So it is based on the type. So if the item type is 1, the current object 1 will be used. If the item type is 2, current object 2 will be used. So what I will do is, for current situation, I will connect this source here, and we will see when I am putting this conditional as item dot type equal to 1, only operator 1 should be used, and for 2 nothing should be done. So 1 second. So operator 1 in the sense the port. So if you go to port, if you check in the center port, operator 2 is at 1. So we need to make 1 for operator 1. So I'll reset it, I'll run this, and you can see operator 1 is used for the same. For second type, no operator will be used. Only for operator type 1, object 1 will be used. So this is this process, this type. Now we will check customized logic tagged resource. Tagged resource is basically a property where a label will be assigned to an item which will state what operator was assigned. So I will stop this. So you can see the operator 1 lifts the part. Now we do not have here condition that type 1 should be lifted only by operator 1. This is on first available basis, the operator will lift the part and take it ahead. So when this part will come on the processor, I'll run and put this. So it is supposed that the resource tag will have its name, that is operator 1. So operator 1 was used for this item. So you can see this, it is going ahead. This is the another property known as tagged resource in the customized logic. Then we have another known as multiple transport options. This is similar to what we have seen here, that is port by case, center port by case. You can add it. Item type, you can have port 1, port 2 selected. But the only difference in this is for multiple transport option you have no transport option here. So if anything is like say item type, I'm putting as item type 1 and 2, I require 1 and 2 center ports. But if item type 3 comes, no transport will be used. So this is the additional feature we are having in this multiple transport option from the customized logic. Another, we have free operators. In the free operator, it is like the name itself says that the operators will be free and no operators will be used for transferring the material from this end to that end. So basically this can be used in order when we are going to use process flow. This will state that the operators connected center portly will not transfer the part, but it will go via process flow. So we'll learn process flow in detail in upcoming videos. So these are the properties we have seen for customized logic. Then we have custom task sequence. So in the custom task sequence, the example number 1, task sequence example 1, you see this is the operator 1 will be putting the parts ahead and going on. So this is the basic task sequence example, custom task sequence. This is used to create a task sequence so that this operator is not assigned to any another task. If we are going to use a single operator for multiple sections, then this operator will complete this task sequence first and then only it will go to the another. So for example, so this is helpful in this case. So if we go for custom task sequence coordinated task 1 example, basically coordinated task 1 example states that this port 1 should be connected to the operator, port 2 can be connected to operator or forklift. So whatever, so what we'll do is we'll connect a forklift here rather than the operator, and we will make a second connection to the port and third connection to the processor, that is the destination item. So for coordinate task sequence example 1, this we need to do. So first center port for operator, second for forklift, third for the destination location, that is processor. When we'll reset, what I'll do is I will change this to combiner now, because we can use this example task sequence only for palette. So I have prepared here. So the source 2 will be generating the pallets and source 1 will be generating the box. Combining, you will have a pallet and a box. So you can see the pallet will be lifted by the forklift and the box will be lifted by the operator. The heavier thing will be lifted by the forklift, that is pallet. So this is the coordinated task sequence example 1, where lighter parts taken by operator, heavier parts will be taken by the transporter. So what I'll do is I'll make this combiner capacity to say 5, so you can see that all the boxes will be taken care by the operator and the pallet will be taken care by the forklift. So you've seen this, and then we have the last custom task sequence, that is example 2, where what we will be having is we will have the dispatchers getting connected. So dispatcher is the device where we can connect multiple operators via single dispatcher. So what I will do is I will bring two operators here, make A connections to them from dispatcher. So the connections are made. 1 second. Connections are made, and we'll make it reset, and I'll make this run. So what is this example? It states that both the operators will be helping each others to load the heavy part. So you can see they are working in sync. Both the operators support each other and transfer the part. So this is example number 2. So we are having 3 examples. First is basic, second is with the help of the equipment, that is forklifts and the operators, and the third, that is coordinate task sequence example 2, will be for a coordinated task, that is both the operators will support each other for doing one operation. So this is custom task sequence. So we have seen object connected by center port by case, global table lookup, by name, no transfer reference. Also we saw customized logic, conditional, tagged, multiple and free. We also saw custom task sequence example 1, coordinated and coordinated 2.